guys, here we go. We're going to start looking at graphing these polynomial functions, okay? Now, the polynomial function here is in factored form, as we could see, which actually makes it easier, okay? Because in the factored form, we can pick up a number of things, all right? First off, and easiest, is to pick up the intercepts. Obviously, the factors are telling me we have intercepts at x equals 0, x equals -1, x equals -2, x equals, okay, +1. So I want to construct a graph, and I want to give myself some breathing room in between those points, okay, so I can show the peculiarities at those intercepts, okay? So, here's my x and y axes, okay? I'm going to space these out because there's a lot of stuff going on at each of these intercepts, and so I need to be able to show that, okay? I did say we had x-intercepts at -2. We've had x-intercepts at 1, -1, 0, and +1. So there's my 4 intercepts. Now, I need to know the end behavior. Okay, the end behavior comes when I can identify the function in the form of y equals ax to the n, I'm not even worried about the trailing terms, which means I just need to know that first term. Okay, now I don't need to expand this out. I clearly can see that this is going to be a second plus a third, so that's a fifth, sixth, seventh power function. So the first term of this would be -5x to the 7th, which is going to tell me everything I need about the end behavior. Since it is an odd power end behavior, I have one end rising and one end falling. Now, which is which? Well, since everything is determined by the first term, ax to the n, we've determined its odd power. One end rises. It actually rises on the left because of the negative coefficient starting us off, and falling on the right. So I'm going to just say we're going to rise forever on this end, and we're going to fall forever on this end. Okay? Now we'll figure out what goes on in between. At these intercepts, the first intercept I encounter is at 2. So I'm going to go, dropping down, I'm going to go through 2. Okay? I'm going to go through it. At the -1 intercept, I notice that factor has a 3 attached to it. That's called a multiplicity. Now, the multiplicity is also, there's a multiplicity with the intercept at 0. The difference is an even versus an odd. So an odd power multiplicity is going to go through the intercept. So it will go through 1, but it will behave kind of like a cubic, which means it's going to have a flattening out effect here somewhat, okay? It's not easy to illustrate that here with this tablet, but hopefully you can illustrate it better. And then it's going to come down for some turning point, because it has to come back up through -2. So we've got this kind of impact going on here. Now, I don't know where that turning point is. It's going to take the calculus for me to define that. My next intercept is at 0, but the 0 has an even multiplicity, which means it's not going to go through. It's going to behave like a quadratic right there and kind of rebound. That's going to be my turning point, is going to be right there. It's going to rebound off of that and then kind of come back up and loop around for this. Again, I don't know where that point's going to occur, okay? But it's probably not going to rise too high because of these multiplicities that we have going on. And then I have one more intercept. So I'm coming through the 0 intercept. I've got to go through the 1, and I will go through it because there's no multiplicity there. So I'm just going to come up. I'm going to have to come up so high and then fall back down again. I don't know how high that's going to rise. And I'm not going to expect you to know how high, because it will take the calculus for us to be able to determine that. So there's my graph. I know it looks a little crude, okay? Again, part of that is because of the tablet experience going on here. But I've illustrated my intercepts. The nature of my intercept, mainly the multiplicity here of 3. And at here, the multiplicity of 2. So I've emphasized that. I've emphasized my end behavior, okay? And I've emphasized all my intercepts, okay? I might just put those in, -2, -1, and 1, and that's it. Now, of course, I'll show you a little bit better version of that via Desmos, and here it is, okay? And again, again, I was unable to find how high these points are. Desmos will clearly find those for you. Obviously, this climbed up real high. I didn't pick up on that. There was no need that you would need to pick up on that either. Okay, there's our graph back there. All right, didn't know how high that climbed. I didn't know how low that sank. But okay, I still picked up on the features of the end behavior, the intercepts, and the nature of the intercepts. So there you have it. Okay. And that's of course what we're going to ask you to do with these graphs here, okay? So now we're going to again have it in factored form, find out the lead-off term, the intercepts, the nature of the intercepts, and the end behavior, and that should do it. There you go.